Hovering a helicopter is a remarkable feat, a testament to engineering and pilot skill. It's a delicate balance, a constant negotiation with the forces of nature, balancing lift and weight to remain motionless in the air. It requires minute adjustments, anticipating every gust of wind, every subtle shift in weight. The pilot becomes an extension of the machine, feeling its every tremor. The main rotor works hard to keep the helicopter suspended, fighting gravity with every rotation. It's a blur of motion, a carefully controlled whirlwind generating the lift necessary to defy the Earth's pull, requiring constant precise corrections from the pilot. These aren't just random movements, they're calculated responses to the ever-changing conditions, a symphony of adjustments played out on the controls. In a hover, the helicopter is like treading water, constantly expending energy just to stay in place. Always working, but going nowhere. All that power, all that effort focused solely on maintaining a fixed point in space. Forward flight changes everything. The dynamics shift, the forces realign, and the helicopter transforms from a hovering platform into a flying machine. The rotor disc tilts forward, creating both lift and thrust, redirecting the energy to propel the helicopter horizontally, propelling the helicopter ahead. The feeling is exhilarating, a release from the constraints of the hover. As speed increases, the rotor blades interact with undisturbed air, encountering a smoother, more consistent flow, gaining translational lift and becoming more efficient. The helicopter begins to fly more like a conventional aircraft, relying on the aerodynamic properties of its rotor system. The transition from hover to forward flight is a dynamic process, a delicate dance between vertical and horizontal forces, demanding careful control as the helicopter shifts its weight and balance. It's a critical phase where precision and anticipation are paramount. From power-based lift to aerodynamic efficiency, the engine works less hard and the helicopter glides more smoothly through the air. During this brief phase, forces are in flux, constantly changing and interacting, and the pilot must manage the interplay of power, lift, thrust, and drag, orchestrating a seamless transition. Mastering this transition is essential for every takeoff and departure. It's the foundation upon which all subsequent flight maneuvers are built. It's not just about moving the controls, it's about feeling the helicopter's response. It's about understanding how the helicopter responds and why. Developing that intuitive understanding is key to becoming a proficient pilot. The process is a dance of inputs, a carefully choreographed sequence of movements, each one timed to ensure a smooth, safe acceleration, avoiding any abrupt changes that could destabilize the aircraft. From standstill to flight, it's a moment of transformation, a transition from potential to kinetic energy. This is one of the first major skills you'll learn as a pilot, a fundamental building block in your aviation journey, and one you'll refine throughout your flying career. Even experienced pilots are constantly honing their skills in this critical maneuver. The transition is the gateway to true helicopter flight, unlocking the full potential of this incredible machine. Before moving forward with the transition from a hover to forward flight, it's essential to lay the groundwork for a safe and successful maneuver. First, carefully assess your departure path. Take a moment to survey the area and identify any potential hazards that could impact your flight. Ensure it's clear of obstacles like wires. Power lines pose a significant threat to helicopters, so maintain a safe distance. Trees. Be mindful of the height and proximity of trees to your flight path or buildings. Urban environments present unique challenges, so be aware of the location and height of buildings in your vicinity. Always have an escape route in mind for emergencies. Pre-planning an alternative landing area can be a lifesaver in unexpected situations. Wind matters. Understanding the wind's direction and strength is crucial for a smooth transition. Whenever possible, take off into the wind for a quicker, more efficient transition. This technique can significantly improve your helicopter's performance. A headwind reduces ground speed, allowing for a more controlled acceleration, and helps you reach translational lift sooner. Translational lift provides increased stability and control as you transition to forward flight. Crosswinds or tailwinds complicate things, demanding precise control inputs, requiring more skill and power to maintain your desired flight path. Be prepared to make necessary adjustments to counteract these effects. Know your helicopter's performance for the day. Consult your flight manual and performance charts to understand your helicopter's capabilities. Consider temperature, humidity, as these factors affect air density and engine performance, altitude, and weight. All of these elements play a crucial role in determining your helicopter's performance capabilities. High, hot, or heavy conditions reduce available power, potentially impacting your ability to transition safely. Confirm you have enough power for both hover and transition. Ensure you have sufficient power margin to execute the maneuver safely. Maintain a disciplined scan of your instruments throughout the transition. Monitor engine instruments, paying close attention to torque, temperature and RPM. Airspeed, ensuring you are accelerating smoothly and maintaining the appropriate speed for the maneuver, and vertical speed inside, keeping track of your rate of climb or descent, but always keep your eyes outside as your primary focus. For alignment and obstacles, constantly scanning for potential hazards in your flight path. This constant scan is crucial for safe, effective transitions, allowing you to react quickly to changing conditions. Preparation and awareness are your best tools for mitigating risks and ensuring a successful flight. Think ahead, anticipate potential challenges, and plan your actions accordingly. Remember, safe flying starts long before you lift off the ground. The transition from a stable hover to forward flight starts with a gentle, almost imperceptible forward push on the cyclic. This is a critical moment, setting the stage for a smooth and controlled acceleration. Think of it as initiating a dance where the helicopter responds to your lead. This subtle push begins to tilt the rotor disc, changing the angle of attack of the blades and angling the thrust forward. The rotor system, the heart of the helicopter, is now redirecting its power. This small, smooth input initiates a slow and deliberate acceleration, a gradual increase in airspeed that allows you to maintain control and stability. It's about feeling the aircraft respond, not forcing it. It should never be a sudden shove or jerky movement. Abrupt inputs can upset the delicate balance and lead to instability. Think finesse, not force. Too much forward cyclic too quickly can cause a dangerous and often unexpected loss of altitude. This is because you're essentially trading lift for forward thrust, and overdoing it can leave you with insufficient lift to maintain your current height. The goal is a controlled, walking pace movement, a deliberate and steady transition that allows you to maintain complete command of the aircraft. As you move forward and the nose pitches down, adjust the anti-torque pedals to maintain heading and counteract the changing torque effect. This is a constant dance between cyclic and pedals. Simultaneously use small, precise cyclic corrections to stay on course and maintain your desired flight path. These adjustments should be subtle, almost imperceptible, keeping the helicopter tracking smoothly. The helicopter comes alive as you direct its energy and momentum, transforming from a hovering platform into a dynamic flying machine. You're now harnessing the power of aerodynamics. Visual cues change dramatically. The ground slides beneath you at an increasing rate, providing a new sense of speed and direction. And as your speed increases, your focus should be far ahead on your intended path, anticipating any obstacles or changes in terrain. This is where you definitively shift from balancing in place, a delicate act of equilibrium, to actively guiding the helicopter forward with purpose and precision. Every input, from the cyclic to the pedals to the collective, should be measured, deliberate, and coordinated, working in harmony to achieve the desired result. The first, gentle push on the cyclic signals the helicopter. It's a clear communication that it's time to fly, to leave the stability of the hover behind, and embrace the freedom of forward motion. Stay ahead of the aircraft by anticipating its needs and responding with coordinated, gentle control inputs. Smoothness is key to a successful transition. Smoothness here, in these initial moments, sets the tone and trajectory for the entire maneuver, ensuring a safe and controlled flight. In-ground effect, IGE, occurs when hovering close to the ground within one rotor diameter. The downwash is trapped, creating a cushion of high-pressure air that reduces power needed to hover. This air cushion makes hovering near the surface more efficient. Over smooth, hard surfaces, ground effect is strongest. Over grass or water, it's weaker. As you climb or accelerate, you leave this cushion behind and need more power. The difference in power required between a low hover and higher altitude is noticeable. Ground effect is a temporary advantage. Anticipate losing it as you transition. Understanding this helps you prepare for the next phase of flight. As you accelerate, you quickly lose the ground effect cushion. At low airspeeds, you haven't yet gained the efficiency of translational lift. This creates a power bucket. The helicopter is least efficient and needs the most power. The rotor system must work harder to keep you airborne, increasing the risk of sinking. Anticipate this demand. Be ready to add power as you leave ground effect. A slight dip in altitude or mushy controls signals the need for more collective. Ignoring these cues can lead to an uncontrolled descent, dangerous when close to the ground. Always confirm you have enough power for this phase before takeoff. Attempting the transition without it can force an emergency landing. preparation and anticipation are critical for safety. As ground effect fades, the helicopter tends to sink. Counter this by smoothly raising the collective, increasing blade pitch and lift. The collective demands more engine power. Apply it steadily, not abruptly. Match collective input to the helicopter's needs to maintain a gentle climb. Monitor power gauges and rotor RPM to avoid overloading the engine. As airspeed increases and you reach effective translational lift, ETL, the helicopter becomes more efficient. At ETL, you can often lower the collective slightly while still climbing. This marks the shift from power-based lift to aerodynamic efficiency. Smooth, coordinated collective use is key to a safe transition. Here's a step-by-step guide for a smooth transition. Start in a stable hover, facing into the wind, with all checks complete. Confirm your departure path is clear, and have an emergency plan. Focus your eyes far down the path for orientation. Gently push the Cyclic forward to begin moving, using right pedal to maintain heading. Move deliberately, don't rush. As you accelerate and feel ground effect diminish, smoothly raise the collective to prevent sinking. Maintain forward Cyclic for continued acceleration and a gentle climb. As you reach ETL, you'll feel increased lift and stability. Adjust controls to maintain a steady climb angle and airspeed. Continue accelerating to your desired climb speed, typically 60-70 knots. You've completed the transition when you're climbing smoothly in forward flight. New pilots often push the Cyclic too abruptly, causing a lurch and loss of altitude. Solution: use small smooth inputs. Guide, don't force. Another mistake is waiting too long to add power, leading to overcorrection and ballooning. Anticipate the need for collective as you move forward. Inputs should be nearly simultaneous. Failing to use the pedals properly can cause the nose to swing. Always coordinate with anti-torque pedals. Skidding sideways is unsafe. Keep the helicopter balanced and aligned. Fixation is another pitfall. Don't focus solely on one instrument or the ground. Maintain a disciplined scan. Look outside, check instruments, look back outside. This loop keeps you aware of all critical parameters. Practice coordination and anticipation to avoid these common errors. Proactive flying is safer and more effective than reactive corrections. The hover-to-forward flight transition is a foundational helicopter skill. Mastery marks the shift from simply balancing the machine to truly flying it. Every helicopter and every day is different. Practice builds adaptability. Mistakes are part of learning. Each one teaches timing and control. Repetition is key. With practice, the sequence of inputs becomes instinctive. You'll learn to sense ground effect fading and translational lift arriving. The goal is to build instinct on a foundation of knowledge. Approach each session with patience and a desire to improve. Celebrate progress. Smooth transitions are a milestone. The transition is your gateway to exploring the sky with confidence.